This pronounced L'Hôpital. Looks like El Hospital, but some French guy's last name, I think. Rule. So number one, use L'Hôpitals to find the limit. So basically, if you have an indeterminate form, the limit becomes easy because you can just use derivatives. Okay. So for example, the limit as x approaches 10 of x squared minus 8x minus 20 divided by x minus 10. All right. So do you agree that if well, let's factor first so you can see it. In case you don't see it, let's factor. What does the top part factor into?
X minus 4 and X plus 5. Wait.
No.
Yeah, I just caught myself.
I think 2 and 10, no?
Yeah, that'd be better. Just realized.
Let's do that. Okay. So technically, I mean, yes, we talked about removable and cancellation, but technically right now, if I plug in 10, I have 0 over 0, right? So currently, if I took the limit, you would end up with this. So this is a indeterminate form. So when you have infinity over infinity type of situation or 0 over 0, then you can use L'Hopital. So you need to have an indeterminate form in order to use this. Okay. So I can't take a limit. So what you do, oops. I'm gonna unfactor it just so it's easier to do the derivative. Let's multiply it out. So what I'm gonna do is put a little LH so I know that we're doing L'Hopital's rule. Okay. So all that means is you take the derivative of the top separately and the bottom separately, and then you attempt to take the limit. So the derivative of the bottom, do you agree that's going to be 1, right?
No, it should be 0.
The derivative of x would be what?
No, it
Oh,
would be 1.
So this part would be 0, right?
yes.
Be 1 minus 0, so we get here. What about the top?
That would be
Is
2x
it
minus 8.
just 2x minus 8?
Yeah, so at this point,
okay. I'm sorry. I think
oh,
was factoring again. Sorry.
that's not good. So I get that rust off, right? Spoon break rust. Okay. So once you take it, once you do L'Hopital, you end up with this. So I still have to write the limit technically. At this point, if I take the limit, because I haven't done it yet, will I have indeterminate form again, like 0 over 0 or infinity over infinity. But can I just plug it in? Am I good?
Yes.
It looks like we're fine, right? So
Yeah.
that'd be 2 times 10 minus 8. So the limit would be not 12. So this is what L'Hopital does. So if you end up with something that you can't take the limit of, but you have one of these scenarios, do the derivatives separately. Don't do a whole quotient rule like usual. Take the derivative of the top, separate from the bottom. Just treat them as two different derivatives. And then if you still have a indeterminate form, just do it again. Eventually, it should let you plug it in. Okay. That's all it is. Are there any questions on number 1?
I have a question. I'm still confused on how you got the 2x minus 8.
Oh yeah, no worries. So when you do the derivative, right? The derivative of all these guys, the derivative of 20 is 0. Derivative of negative 8x is negative 8. And this is a power rule, right? So you bring down the 2, subtract 1, this becomes an 8, this becomes a 0, right? So we're just doing it term by term. Just doing power rules. Do you remember?
Like a little bit, I think. Let me write this
Did you want to see more steps?
down. If you can.
Yeah, that's fine. So the derivative step, right? Remember, I know we just got back, right? So that's okay. You bring down the 2 and then you subtract 1, right? So that's where the 2x comes from. And then this one, you bring down the 1, we subtract 1. And derivative, any constant will always be 0. So this becomes 2x. This becomes 8 times x to the 0 minus 0. X to the 0 is a 1, so this ends up just being this. Okay. So just all we're doing is power rules to every term.
Oh, okay.
I think it was like 3.2, I think, when we first did it. Okay. Let's make a note here for you. Derivative of the numerator. So just remember, when you're doing this, pull out the derivative rules. Okay. Just... All right. Any question number 1? I'm going to start another one. Okay. Number 2. The same instructions, use L'Hopital. But you should always check if you have indeterminate forms. Define the limits. This is basically another technique to do limits. We did quite a few in chapter 2, but I think this one's like one of the easier ones, but you have to know derivatives in order to do it. So you have to do chapter 3 first. Okay. So here it is. Do you agree if I put 0 in there, I'm going to have 0 over 0.
Yes.
And if you don't see it, I'm going to do it anyway. But since this is an indeterminate form, use L'Hopital. All right, so I can't take the limit. So let's write it again and then take the derivatives. So let's do L'Hopital right here. So the derivative of the denominator is going to be, oops, I have to write the limit, shoot. You always write the limit notation until you take the limit. Yeah. So I haven't done the derivative yet. My bad. I guess I'm a little tired. What's the derivative at the bottom?
1.
So that one's not too bad. But what about the top?
Is it 1/2 and then 1 minus x squared is in parentheses and then it's all to the negative 1/2 minus 0?
So this would be -1/2. So that's true. But then you gotta do the chain rule. So derivative of the inside would be this,
2x.
right? Okay. And so this, so that's cool. So before I take the limit, let's try to make it pretty. Right now it's kind of disturbing. So negative x over 1 minus x squared 1/2. So I fix the negative power. So I plug in 0. I get 0 negative over 1 minus 0. So that'll be 0 over 1, which is 0. So we are allowed to plug in the limit without issue, but it's 0. So any questions on the algebra stuff on the second line here? Or here? Or the derivative step? Excuse me. Okay, let's do another one then. Find the limit with L'Hopital. Shorten this up. So the limit as x approaches 0 of sine 6x over sine 5x. So if you take the limit, you agree this will be 0 over 0, right?
Yes.
So this tells us that you can do L'Hopital. So let's do it right here. What is derivative of sine 6x?
Cosine 6x.
And then times the chain rule, right? Cosine 5x times the 5. Forgot the limit again. Dang it. There'd be 6 cosine 6x over 5 cosine 5x. Take the limit. That will be 6 cosine of 0 over 5 cosine of 0, which is 6 over 5.
Can I ask question?
Of course.
Can I ask question?
Yeah, what's your question?
So why is it there's a 6 in front of the cosine 6x?
So that's the chain rule, because derivative of sine 6x would be cosine 6x times the derivative of the inner function. Derivative of 6x is 6. So the derivative of sine 5x would be cosine 5x times the derivative of 5x, which is 5.
Okay.
So I skipped the chain rule here.
Okay. Could you like that? I I want to see I want to see the steps without the skipping.
Okay.
Thank you.
Let's just rewrite it then. No big deal. So the derivative will be cosine of 6x times the derivative of 6x, remember? And then derivative of sine 5x will be cosine times the derivative of 5x. So then take a limit. We'll end up with 6 cosine of 0 over 5 cosine of 0, which is 1 over 1 times the 6 and 5. Any question on number 5? That makes sense?
Yeah, makes sense.
All right. Let's do another one. Maybe 1 or 2 more and we'll move on. Is the idea making sense?
Yes,
It's not too bad, right?
not bad at all.
I just have a quick question. On the last one, was it to the first power? Or what was the
Power of,
after like the
oh, this is the quote, the derivatives little quote there.
Oh, okay, okay. I thought it was, but I wasn't sure if that was like the first.
Needs more of a curve, I guess. So we take the limit right now. Well, actually, this is going to infinity, so we have to right away do L'Hopital, right? You see what I'm saying? It's going to be infinity over infinity, so take the derivative of the top and bottom. What is the derivative of the top?
Six X
Six
plus
X
nine.
plus 9.
Yeah, 6x plus 9. Bottom will be 4x, right?
Yes, sir.
Now notice I still can't take the limit because it'll still be infinity over infinity, right? So do it again. What's the derivative of this top part?
6. 6 and 4.
Yeah, so it'll be 6 over 4. At this point, take the limit because there's no x anyway. It'll be 6 over 4. So we just keep taking keep doing L'Hopital if you keep finding another indeterminate form. So if it keeps happening, you just got to keep doing it. Once you're able to take the limit, go for it. Does that make sense?
Yes.
Um, yeah, well, let's move on to something else, I think. Yeah, let's do 4-1, and then we'll call it a day, I think.
Okay.
You have any questions on L'Hopital before I move on?
I personally do not have any questions.
I just had a quick question. If there was like a particular reason why we're going out of order, because I thought 5.6 was on the fourth exam.
I was just getting it out of the way while derivatives are fresh.
Oh, okay.
It doesn't really matter. I think you're right. I don't think it's gonna be on test 3. Or sorry, 2. No, it is on test 2. Yeah. Sorry, I'm getting my numbers mixed up. Test 2 is chapter 3. Test 3 is chapter 4. So it might be actually, but we'll figure that out later. Okay. So in chapter 4, we're going to apply the derivative to find maximums and minimums of two-dimensional graphs. So if you have, let's say, I don't know, let's call this F, some random graph. Call this F of X. So if you're coming from the left, right, approaching that hill right there, just running up that hill, do you agree that I'm increasing?
Yes,
Yes.
And then after the hill, just picture a little car. Do you agree that it's decreasing?
yes,
So right here at the peak, the derivative is 0, so if we have a change from increasing to decreasing, we're going to have a maximum. That's the stuff we're going to talk about. And finding this point would be called a critical number. Okay, so over here, same deal. If we have decreasing and then increasing, that'd be a minimum. Okay. So this whole chapter 4 is going to be using these ideas to find those peaks and valleys. All right. That's the goal. So critical numbers are values that make your derivative equal to 0. So critical numbers could be these maximums and minimums. All right. Could be. So if they make the derivative 0, how would you find the critical numbers?
Factoring and equal to 0.
Yeah, pretty much. Just find the derivative, set it to 0, right? Solve it. Might be probably a lot of factoring. So basically, just set it to 0, solve. The number 5 in your homework. Find the critical numbers given this function f of x equal to x to the 4th minus 8x cubed. Step 1. Find f prime. So what is the derivative?
Four x power 3 minus 24x power 2.
Yeah. So there's a derivative. Step 1 is find it. Step 2, set the derivative that we just found equal to 0 and solve for x. These solutions will be your critical number. Or numbers. There might be multiple solutions. All right, so fx 4x cubed minus 24x squared equal to 0. We should factor that they both have x squared and 4, right? Mm. You agree with the factoring?
Um, sorry, what was that? It's busy writing.
Factoring, okay.
Yeah, I'm okay.
So, factored it. Set it to 0. X is 0, X is 6. So all they asked for was the critical numbers. So we found 2 of them. That's how you find them. Any questions on finding critical numbers?
So for the most part, you just find the derivative and then like factor it and then solve for each one.
Yeah, just as long as it's set to 0, yeah.
Is this like the same thing as finding like the amplitude?
Not necessarily. Amplitude usually was for what's it called? Trigonometric functions. But the trig functions do have max and mins that can be found. So I remember you remember back with quadratics, right? You'd have the peaks or the vertex, right? So we're basically finding any of those peaks on any function. Because before on quadratics we had a formula, but now we can use this technique for any function. Doesn't matter. As long as you can take a derivative, then you can attempt to find a max or min, which becomes important for like if these functions are like, I don't know, cost or profits or something, or energy use, then people care. Right. Any questions on 5?
Yeah, hold on, I need to finish writing this real quick.
Okay.
Zero. Okay, you can go ahead.
Excuse me. Right. So on the next one, we're going to actually find the extrema values. But we're going to do it on a closed set. Find the absolute extrema of f of x. So whenever you see extrema, that means the maximum and the absolute maximum and absolute minimum. Okay, it's just a general term for either or for both. But they're putting it only on this interval. So there's a theorem in optimization and probably in this book that says that if you have a closed interval and you're trying to find extrema values, then they will occur at the critical numbers or at the boundaries, at the endpoints. So you have to find the critical numbers and then test the critical numbers and your two endpoints, and then see, okay, what's the biggest, what's the smallest? That'll be your max and min, okay? So step one, find the critical number, critical numbers. So step one, sub-step, right? Find the derivative, we said. That's gonna be this, right? You agree with the derivative. I'll stop for a sec.
Yes.
Alrighty. Step two. Step two, I guess. Set this to 0 and solve like we did earlier. Factor 3x, and it looks like we're going to get x minus 1. All right. So step two. Before I move on, are everyone comfortable finding the critical numbers, the 0 and the 1?
Yes.
Okay. So step two wants you to test the critical numbers and the endpoints. By plugging them in. F of x. The biggest output will be the maximum, and the smallest will be the minimum. All right, so here we go. So plug in 0 into the function because that's one of the critical numbers. That'll be 0 cubed minus 3/2 times 0, which is 0. Plug in 1. That'll be 1 cubed minus 3/2 times 1, which is negative half, right? Now plug in f of negative 1. Will be negative 1 cubed minus 3/2 times negative 1. Will be minus 1 plus 3/2. So that'll be a positive half. Now the last endpoint will be the 6. So 6 cubed minus 3/2 times 6. It's 216, right? Minus 3/2. Hold up, I think I made a mistake. There should be a square here. Which would make this minus. Which would make this -5 halves. Squared 36. It's 162, right?
I have a question. From where we get the -1?
The -1. So remember, the idea is you test
Mm,
criticals and you test the endpoints of the interval.
okay, now
We're
got it.
basically closing this function on here.
Yeah, thank you.
Okay. So what's the biggest one?
F6 is the max.
Yeah, so the maximum is at 6 comma 162. What's the minimum?
-1, -5/2.
Yeah. So because it's closed, we can do it this way. Any questions on number 9?
No.
So you only do this when it's closed. If it's
Yes.
open, then all you have is the critical numbers to work with, and you got to do other stuff. Let's do one more, and then we'll call it a night for 4.1. You guys are cool so far, you said? Making sense?
Yes.
Let me know at any time. So what do we do first?
And the derivative of the function.
Yeah, step 1. Find the critical numbers, which requires the derivative. So what is f prime?
-3 sine x.
-3 sine x. So that's the first part. Second part is set it to 0, right? When is sine equal to 0? Unit circle 0, pi, 2 pi. That would make sine 0, correct?
Correct.
So those are your critical numbers. Step 2. Plug in the critical numbers. And the endpoints. Here we go. Pi. The cosine of 0 will be 1, right? That'll be 3 times 1. Cosine of pi will be -1, so it'll be 3 times -1. So what is my maximum?
Right. Well, are we doing this when we're entering this into the calculator? Do we keep it in degrees or radians?
Well, we're using radians, so it gotta be radians.
Okay. So yeah, the max is, it's both 0 and 2 pi, it looks like.
Yeah, it looks like, well, remember, trig functions are cyclical, right? So it's gonna hit that maximum twice.
Mhm.
Because the amplitude is 3, right? And then minimum will be okay. Any questions on 4.1?
I have a question.
Mhm.
If the numbers that were given to us were 0 and 2 pi, and the answer we found was 0, where did we find the single pi by itself?
Oh, that was one of the critical numbers because sine is 0 at pi. Using your unit circle, or if you remember the graph of pi, if you remember the graph of sine,
Oh, with sine of x equal. Oh, okay, okay.
yeah. So which angles make it 0? It's going to be these 3. It just so happens those happen to be the endpoints as well. So
Oh, okay, that makes sense.
there it goes. All right, let me take roll.